I'm Bruce Quirk. I'm the USGS UAS liaison at this point. I'm also have another hat I wear, which is I'm the Deputy Assistant Director for the UAS Division in the American Society for Photogrammetry and Remote Sensing. And I've been doing remote sensing probably since the 80s. So I've got a lot of experience in aerial systems and satellite systems and GIS and applications of the data. What I want to do today is talk a little bit about some of the UAS activities we're doing as it relates to natural resource and wildlife activities. The systems you see on my screen right now, and hopefully you do see my screen, the tool we currently have been using is the Raven, which is on the far left. It's a fixed wing with a USGS banner across it, and the other one is in the top middle. It's called a T-Hawk. And we got both of these systems access from DoD, and they've been very good performers for us in the last 4 or 5 years. The systems that we currently are purchasing are shown on the top left, which is a helicopter you can see, and then on the top right, which is a quadcopter, and right below that another fixed wing. Those are the three systems we're currently purchasing. We have IDIQ contracts, and we'll get a number of those systems out to the USGS and Department of Interior bureaus this fall yet. The systems on the bottom right is an MLB SuperBat, which we received 5 of those from NIST, and we're using those for various applications work. And the one at the very bottom middle is called an Octavian Nova, and that our co-op unit in the University of Florida is using that. And one of the benefits of that is it is waterproof. So those get you a feel for the kinds of aircraft we're currently working. Now, let me, and really maybe stepping back just for a second and talking about why we're using remote sensing in the first place, it really is about the data. And if you look at the graphic on the right of this particular slide, all those areas that are colored are areas that the Department of Interior has management responsibility for. And that's about 20% of the land mass in the U.S. So with all that land that we have to monitor and declining budgets, we've turned to remote sensing to provide data. And the graphic on the left then shows you the types of remote sensing we've been using, from satellite, Landsat 8, down to various aerial systems, down now to unmanned systems. And on the very bottom of this graphic, it kind of gives you some feel for the pros and cons, if you will, of each of those different methods of data collection. Satellites are great. They give you, periodic observations, barring any cloud cover, and they give you a regional or give you a very continental scale of imagery that you can use for particular applications. Manned aircraft we've used quite heavily in the past. However, the expense of manned aircraft we've kind of lowered our use of manned aircraft in the recent years. We do a lot of field work, obviously, going out in those areas that you see on the map to do various kinds of project work. And then UAS, though, is something we've gotten involved with in the last 4 or 5 years. And it's kind of unique in the remote sensing area because it allows you really to go out and get the data when you need it. So it really is the science driving the data collection. Satellites, you're kind of held captive to whatever orbit they are, whatever crossing time they have, if it's 10 in the morning or 3 in the afternoon. But with UAS, our scientists can go out and use it as another piece of field equipment and get data at 8 a.m. in the morning or 3 p.m., switch sensors, and continue to get data that they need. So it kind of gives you a feel for how remote sensing is providing data to us in the USGS and the Department of Interior. Several years ago, we came up with this strategy that you see now. Our focus has been on small unmanned aircraft systems, and the ones that you saw on the first slide are all considered small, which means they're all under 55 pounds by the FAA standard. We try to leverage DoD excess equipment, as I mentioned before. We do a lot of collaboration and partners. We work a lot with NOAA. Some of our other bureaus work with the Coast Guard up in Alaska, work with NASA as well. So we try to work with the other agencies and universities as well to take advantage of each other's capabilities when we can. What we've been doing these last 4 or 5 years is something called operational test and evaluations. And so what you'll see in the applications I'm going to present in a few minutes are just ideas that people came to us with, and they say, hey, can you use the technology to do this? And so what we've done is try to take a wide variety of projects throughout not just the USGS, but the Department of Interior, and throw them at the technology and see what would happen. If it doesn't work, what have you. And as I mentioned before, we're in the process of procuring new systems for our scientists and our engineers. About in 2008, after looking at the technology for a couple of years, we decided to establish a national UAS project office in Denver. Mike Hutt was the original lead of that. He has since retired, and Jeff Sloan is now the lead of that organization. And really, that's the group that really does all our operational activities. They've been doing the software test and evaluation phase, not just with the other bureaus, but also with the Department's Office of Aviation Services, which is another key group that's helping evaluate the technology. And along with these projects that we've been flying, they also look at new technology, particularly things like sensors, and trying to look at the way you can take the data we have and integrate it with other data and produce new products and capabilities. The slides or the pictures you see on this particular slide really are ground control stations at various points, from Colorado in the upper right to West Virginia in the lower middle, and even to some of the work we did on the Missouri River launching a Raven from a boat at this point. This is just kind of gives you a quick summary of some of the applications we've been running for the last, again, 4 or 5 years, from wildlife management to inspections to research to public safety, and I'll go into more detail on some of these right now. One of the first projects we did was with the Fish and Wildlife Service, and we were looking at migratory birds, in this case sandhill cranes, and their question was, one, can we get an accurate count of the cranes as they migrate through, in this case, Monte Vista, Colorado, the refuge they have there. And not only can we get an accurate count, can we also not disturb the birds, because obviously one of our tenets is not to disturb the environment that we're monitoring. We did a number of flights over this area, and at the same time we were doing our flights, the Fish and Wildlife Service was doing the traditional counts in the field where they had biologists out trying to estimate the number of sandhill cranes in the refuge. Just drop to the bottom line here. I think our estimates and their estimates agreed to about 4%, 4.5%, something like that. So the wildlife biologists were very, very happy with that result. And at the same time, since we flew at civil twilight in the evening, we didn't really disturb the birds at all. So we tried it at different altitudes, and it turns out that usually at 150, 200 feet, we were good without disturbing the sandhill cranes. And again, we got a very good estimate. The other thing to note is the very bottom note on this slide is that an estimate of cost is about $2,500 for us to go out and fly this mission, and a traditional manned mission would be anywhere from $25,000 to $35,000. So it was about 10% of the cost of a traditional manned mission. Another project we did with National Park Service and others, Bureau of Reclamation, was to fly some imagery below an Elway Dam, the dam in Olympic National Park in Washington. The issue here was they were going to remove the dam after 100 years of service, and obviously 100 years of sediment had piled up behind that dam, and the question really was, when that dam's removed, that sediment heads downstream, what kind of impact does it have on downstream environment? And so we, in case, used the Falcon in this case, and flew a number of missions along the lower part of that river to understand and document, really, monitor what was happening when the sediment was released at the dam site. Another quick example, and this is in West Virginia for the Office of Surface Mining. Typically, their investigators, inspectors have to go out to a mine that can be, several hundred acres or several thousand acres, and try to go out and understand if the VC, if the mine operator is really complying with all the regulations and the activities that they should be. And traditionally, they would do this on foot, and it could take them a day or two to walk up and down these hills to really inspect the site and make sure that everything is being followed. And obviously run into things like stakes and other obstacles that you might not want to run into when you're doing these inspections. We've flown several missions now for the Office of Surface Mining, and you can see some of the imagery here where we can go out and document the high wall, the length of the high wall, the height of the high wall. We can document large surface features, as you see in the middle there, that you may not be able to see when you're walking on the ground. We can document potential drainage problems, as you see on the far right. And also, it gives you, again, a different view, an aerial view that they wouldn't normally get of the sites. The idea here being that we can go out in a couple hours, collect the imagery, and then they can go back in the office and do the analysis that they need. The Office of Surface Mining now is in the process of buying their own systems and setting up a capability within their bureau to assist their inspectors with this type of work. Another different example, this is actually BLM and again the Park Service. In this case, it was White Sands National Monument, and the idea here was to go out and locate and document these Pleistocene trackways. The shifting sands down on White Sands, these things appear and disappear over time, and the issue here was, can we go out and find them and document where they are? And when we say document, we're talking about a couple centimeter resolution here from these systems. Again, a very successful mission with the Park Service to aid them in understanding where these areas are and where they need to be preserved. Another example, this time we're along the Missouri River on erosion. This was with the Lower Rural Sioux tribe. As you see the image in the middle lower right there, they had an idea in 2004 where the shoreline was, but their question to us in 2012 was, what's happened to the shoreline in the intervening 8 years? And we were able to fly along the shore and give them imagery, ortho imagery in this case, to document how the shoreline had eroded between 2004 and 2012. So this is a very easy, simple way to monitor erosion rates along the Missouri River for their tribe. Another example, this is more of a monitoring in the sense that we've been flying the Dubuque landslide in Colorado for a number of years. You can see the imagery here. The first set is acquired in June of 2013, and the bottom set is in October of 2013. The systems that we used are on the right there in the imagery. I think the real interest is probably this slide. And what we've done is there's something called structure from motion, and basically we can create point clouds from the overlapping imagery that we take. And from that, you can start looking at how things have changed over time. And these images really indicate that if you just look at the green part, that's the area that probably indicates that it's moved the most over that period intervening time between June and October. So again, it's a very fast way of going out and collecting imagery and I'm trying to understand what's happening in your particular project area. So just a quick summary of some applications that we've talked about and maybe some possible Alaska projects. We've done a wide range of applications as I've shown, and all sorts of different terrains and environmental conditions. We've flown both day and night. We produce different types of products, and I'll mention more about the products in a minute. Again, one of our tenets is not to disturb the environment we're flying over. Mostly over small areas and mostly over public lands. If we do fly over private lands, we ask for permission from the landowner. Because of the FAA regulations, all of our work is line of sight, so the pilot always has the aircraft in his line of sight when they're doing flying. And usually these missions, there's multiple flights. So we might go out to the Office of Surface Mining, and we may fly 2 or 3 different flight lines, if you will, do different flights in a particular day to get the information that they need. The table at the very bottom gives you some ideas of some of the work we've talked to with the Alaska Science Center. There's very interest in doing UAS for aerial surveys of onshore polar bears, and it gives you kind of an idea where and across some border islands, the types of imagery they need, and then the types of potential flight dates, September through October of next year. Besides polar bears, there's interest in walruses, and you people from Alaska know these issues much better than I do. And there's also interest in coastal erosion. So the third line down here really talks about some of the areas along Point Lay, Alaska, where they want to monitor coastal erosion. And again, it's pretty standard, photography for us to acquire and produce products from, using the structure from motion method I mentioned before. And then there's some sea otter work that several scientists up in Alaska also want to pursue. So, what we're finding as the word gets out for these various missions, that there's a lot more interest in trying these new types of applications. And some of these have already been done. NOAA, I know, has worked on some of the sea otter work with some of our scientists in Alaska already. These are some of the geospatial products. Again, this is remote sensing data, so once you go through the orthorectification stage, you can put it into any kind of ARC product line or NV product line or any of those to process it like a GIS remote sensing data set that you normally would do with satellite or other data sets. But again, we can get color data, we can get color infrared data, we can then produce NDVI images through the point clouds, we can produce various elevation models, what have you. We can do feature extraction. In the case in the middle there, what you see is some work we did in the Mojave area, and those red dots represent Joshua trees that we were ended up mapping for the National Park Service. And also on the very bottom on the right, you can see that we can do volumetric measurements. So in some cases, if you're interested in how much cut or fill that you need to have, we can estimate it very accurately with UAS data. Some of the sensor technology, we started out with various DoD sensors, thermal and what we call EO or RGB sensors. We have since moved way past that, and now we're investigating multispectral and hyperspectral systems to put in our aircraft along with LiDAR systems. This just shows you a project we're doing at the University of Florida. We have an octocopter, a DJI S1000, and what you're seeing here is really the gimbal setup that they've developed to hang from the octocopter, and the image in the upper left shows a DSLR camera and a thermal sensor, a FLIR thermal sensor that we have right now configured for that, and we're soon going to put a Ricola sensor in there as well. So again, we're very interested in getting these types of data for our scientists and for our investigations. So quickly in summary, really over the last, again, 4 or 5 years, we've seen 3 tangible benefits from our work. One is the science. As I mentioned, we really can get out there and get data that we may not have been able to get before and make a digital record, and also be able to go out there and repeat the acquisition of that data when we need to. Most people don't realize that for safety, the wildlife biologists, the leading cause of their deaths is aircraft related. If you think about it, they're flying low and slow in a helicopter or in a winged fixed wing aircraft, and something happens, you don't have a lot of time to respond. And consequently, the wildlife biologists are one of the really early adapters of the technology, because it does really lower the risk when they go out and do field work. And as I mentioned before, savings, from our experience over the last years, we figure that it costs us about 10% of what normally would cost a manned flight. Now, in our discussions with the Alaska Science Center and some of the people up there about Arctic operations, obviously we're interested in collaborating, and we've already talked to Robbie Hood and NOAA about some of the work we might be able to do with her group up there to get some of the data sets we need. There's other issues, as you guys are well aware, logistics and getting out to the sites to get the data that you want. The regulations, and the FAA has probably a keen interest in making the Arctic a little bit more open for operations than they have in the lower 48. And things like beyond visual line of sight is more practical up there than it is down here. And then also environmental conditions. We don't fly too often in 40 below weather, but I know in Alaska there are sometimes you do get those situations we need to collect data. So finally, I guess questions, and these just images you see here are just some Fish and Wildlife people in the Kern National Wildlife Refuge after we collected some data there in 2013. The graphic on the right is just our estimation of how the number of hours that we do across the department are going to be increasing in the next few years, because again, this is really taking off of our scientists across the bureaus in the department. And a very important link in the very bottom there, our website. If you have any questions about where we're going to be flying, is we have a calendar on our website, or our past missions or past capabilities. Please go out and look at uas.usgs.gov. And with that, I'll turn it back over to you, Jessica, and if you have time for questions, that's great.
Hey, this is Renee Crane from NSF. I joined mid-presentation. Sorry for being late.
Okay.
Bruce, I have a question about the volumetric studies. Do you want to flip back to that slide?
Yes, ma'am.
Are those, so can you do shallow lakes and things? Or these of, did you say fill? It's
This actually is a site where they've been doing some mining, and so this is just estimation of piles of ore or what have you.
Mm-hmm. Recoverable material, essentially.
Yeah. Yes.
Okay. Does anybody else have questions?
Yeah, this is Carl. Bruce, how many total aircraft, I guess if you could use that term, do you have, and how many total staff do you have that utilize those aircraft?
Well, when we got the DoD excess equipment with the Ravens and T-Hawks, we ended up with over 100 systems altogether. Since we have those, we've been, some of those have, just because of use, are not really operational anymore. We still probably have, 50 total aircraft that we've been using. What we hope to do with the new aircraft that I mentioned at the very beginning is stock up our Denver group in the USGS and also our group in Flagstaff. And I think what you're going to see is some of our other science centers in the USGS purchasing those aircraft. Likewise, the Bureau of Land Management is going to be buying some aircraft. So it's hard to estimate right now how many we're going to end up with by the end of the year. Definitely multiple numbers of all three of those that you saw. As far as the number of active pilots, I think probably across the department is around 12 or so that are actually flying on a monthly basis or a weekly basis. And those, again, are scattered in Denver and Flagstaff and other sites as well.
And you need a minimum of, 3 people per project when you operate one of those?
No, it's a minimum usually of 2. We usually have a pilot and observer, and usually the pilot and observer both can be pilots. They both are certified to fly. And then when we go out in the field, we usually end up having the PI comes out, or in fact, if you look at the one image here, I'll show you real quick. Going back to it becomes really popular when we start flying. And if you look at the image I have on the screen right now, the lower right, those are all the people that showed up when we did the flights in Monte Vista. So typically we'll have 2 people. Some of the systems we're trying to get to is a 1-person.
Bruce, are you still there?
Yes, I am.
Oh, okay, sorry. So I have a question about sort of developing these collaborations with academic researchers. So if people have an interest where essentially you guys are already poised and ready to collect the kinds of data that they want, is it something that researchers should come to USGS to try to arrange, or is it, and at the proposal stage, or is it something where through like NSF's logistics program, we would do an agency-to-agency agreement to buy services from USGS? Do you see what I mean?
Yeah, I guess right now how we've worked it is interested university researchers have just contacted us, and if it turns out we're flying in the area, or if there's a mission that we want to work together with them, we'll just do it. We haven't gotten the amount of interest where we're going to start thinking about agreements with, like, through the National Science Foundation, but we could in the future. I mean, it's not saying we wouldn't, but right now it's been more of a colleague-to-colleague collaboration that we've had with people.
Okay, thanks.
And say, Bruce, do your pilots have to be actual pilots?
No. All they have to be is, we have a training program that's been certified by the FAA, and so they have to go through and get certified on the aircraft they'll be flying, and they get carded. The DOI has a card that they give each of the pilots, and they have to maintain their certification by either simulator flights or actual flying missions.
Okay, thanks.
Any other questions? I'll be happy to, if you think of something later, please feel free to drop me an email, quirk@usgs.gov, and I'll answer the questions then as well.
Great, thank you very much.
You're welcome.